So for this question, we have to, first you want to read the question. So Zaid is helping his classmates get ready for their math test by making them identical packages and of pencils and calculators. So we need identical packages of pencils and calculators. He has 72 pencils and 42 calculators. He must use all of the pencils and calculators. If Zay created the greatest number of identical packages possible, how many pencils will be in each package? So the main component here is how many pencils will be in each package. So for this question, we have to find the greatest common factor because we need the greatest number of identical groups. And then we have to use that. So the greatest number of identical groups is going to be the greatest number of identical packages of pencils and calculators. So that's not going to be the answer to our question because the question says how many pencils. This is the question that you want to address here. So the first thing I'm going to do is find the greatest common factor. So I'm going to make sure I stay organized. So I'm going to write pencils. And then I'm going to start with 72. And I'm going to use prime factorization. So 2 factors to make 72. Now you can use 9 times 8. If you don't know your multiples of 9, you can use 2. And since we know that 72 is an even number because in the ones place, we have a 2, a 4, a 6, a 8, or a 0 in the ones place. So that tells me 72 is an even number. So I know I can start with 72 and divide it by 2. 2 goes into 7, 3 times 2 is 6. I subtract 1 left over, 1 remaining. I bring down my next number, which is a 2. 2 goes into 12 6 times. So that means that 2 times 36 will give me 72. So the 2 factors I want to use is 2 and 36. 2 factors to make 36. You can use 4 and 9, or you can use 6 times 6, or you can use 2. Whichever one you want, you can use. I'm going to use 6 times 6. 2 times 3 are 2 factors to make 6, and 2 times 3 are 2 factors to make 6. Now I'm going to find the prime factorization. Well, I'm going to write my prime factorization down for 72. And remember that 72 represents the pencils. So 72 is equivalent to 2 times 2 times 2 times 3 times 3. So if I multiply 2 times 2 times 2 times 3 times 3, you should get 72. That's how you can check to see if your answer is correct. Now I want to find the use the prime factorization tree to find the prime factorization for 24. I know 2 factors to make 24 are 2 and 12 because 2 times 12 equals 24. I'm going to circle 2 because 2 is a prime number because the only factors are 1 in itself. Then I'm going to keep going with my 12. So I'm going to use 2 times 6. Doesn't matter which 2 you use. You can use 3 times 4. And I'm going to circle my prime number. Then I'm going to draw 2 branches coming from my 6. 2 factors to make 6 are 2 and 3. And I'm going to circle both of those because they are prime. So the prime factorization for my calculators, 24 is equivalent to 2 times 2 times 2 times 3. Now I can find the greatest common factor. I'm going to circle what they have in common and bring it down so I can factor out a 2. I can factor out another 2 because they both have it in common. I can factor out another 2 because both prime factorizations have this in common. And I can factor out a 3. So I can multiply all of the common factors that I factored out to find the greatest common factor, which is 2 times 2, which is 4, 2 times 3, which is 6, and 4 times 6, or 6 times 4, is equivalent to 24. So that means the greatest common factor is equivalent to 24. So 24 is not the answer to a question. 24 is the greatest number of identical groups, identical packages of calculators and pencils. Now the question asks how many pencils will be in each group. So if you have 72 pencils and you're making 24 identical packages, if you start with 72, divide it evenly between the 24 packages, you're going to end up with 3 pencils in each package. So that's the answer to the question. How many calculators will you have in each package? Since we don't have a number left over, once we factor out 24, we're going to have 1 calculator in each package. So the answer is Zaid will create packages with 3 pencils. And that's the final answer. Remember, the greatest common factor is going to tell you the greatest number of identical groups. And sometimes you have to use the greatest number of identical groups to figure out the actual question. So let's say we wanted to rewrite this using the greatest common factor in the distributive property. So let's say we have 72 plus 24. This is not the answer. The answer is 3. I'm just expanding this. So you would factor out 24. When you factor out 24 for 72, you have 3 left over. So that means 24 times 3 is 72. The sign stays the same in the middle. And 24 times 1 will give you 24. So this is how you will rewrite using the greatest common factor in the distributive property. Now let's say you factored out a 2. If they said rewrite it, if I said rewrite using the greatest common factor in the distributive property, if you factor out a 2, this is wrong. Even if you put 36 here and 12 here. 2 times 36 is 72, and 2 times 12 is 24, but 2 is not the greatest common factor. So remember, you have to make sure you factor out all of the common factors. And you can see here that 36 and 20 and 12 can be simplified. So since 36 and 12 can be simplified by the same number, common multiples, that tells you that 2 is not the greatest common factor. So keep that in mind. Moving on to the next one. Emma has 12 pencils, Alex has 9 pencils, and Michael has 33 pencils. Use the greatest common factor and the distributive property to find the total number of pencils Emma, Alex, and Michael have. Write each number as the product using the greatest common factor and apply the distributive property. So we have to keep in mind, we have to apply the greatest common factor. So if you don't pick the greatest common factor, then you could get this answer wrong, and if you don't apply the distributive property. So that means you need to factor a number out, you need to have parentheses, you need to have 3 terms inside of the parentheses because you have 3 terms here. So we're going to find the prime factor, we're going to use the prime factorization to find the greatest common factor of the 3 numbers. So I'm going to write the prime factorization for 12, which is equivalent to 2 times 2 times 3. And the prime factorization for 9 is equivalent to 3 times 3. And the prime factorization for 33 is equivalent to 3 times 11. So I have to factor out any factors that all 3 have in common. So I see the lowest number that I have is a 2. But 9 does not have a 2, nor does 33. So I cannot factor out a 2 from each one of these prime factorizations. So I'm going to look at the next number, which is a 3. I see a 3 in all of the prime factorizations, so I can factor out a 3. Now I don't have anything else to factor out because none of the numbers have another common prime factor. So the greatest common factor of these 3 numbers is just 3. So I'm going to rewrite 12 plus 9 plus 33 using the greatest common factor, which is 3, and a distributive property. So I'm going to factor out a 3. I'm going to make sure I keep my 2 signs the same. That's in the middle. And I need to put 3 terms inside of the parentheses, the 1 term. So 3 times what number will give me 12? Well, if I look at my prime factorization, if I factored out a 3, I have 2 times 2 left. So that means 3 times 4 is equivalent to 12. Then I need to figure out, okay, 3 times what number will give me 9? If I look at my prime factorization, once you factor out this 3, you have a 3 left. So that means 3 times 3 is 9. For 33, once you factor out this 3, you have 11 left to make 33. So that means 3 times 11 is 33. So that is the answer using the greatest common factor, n, which is 3, and the distributive property. Now you will have questions like this on your test. The next one, so on your next test, after this test on Thursday, this will be on your next test on the 21st. You will see writing word phrases, all of chapter 3. Okay, so we want to write a word phrase for the following: half of a number and half of the sum of 2 and a number, half of the sum of a number and 18 plus 10. That's one way to say it. Or you can say 10 more than because we're adding 10 to what? Half of the sum of. So 10 more than half. So this is 10 more than, which is right here. And then half the sum of, remember this is multiplying, and so you need parentheses. So you need to say the sum of, because addition is sum. So half of the sum of what? A number. You could say n, and remember quotient, sum, difference, product. You put that operation symbol right where it says and, so that's our plus sign, n. And then you will put 18. All right, so the next one. 1/2 times n minus 18. You can say that. Or you can say 18 less than, and I'm just going to write the numbers. 18 less than half of a number n. $18 less than half of a number n. So 18 less than is subtracting 18 from a number. So that means it will go last. And then half is to split a number in half. If I say half of 10 is 1/2 times 10. So I'm taking half of a number that I don't know. And since the number is unknown, you will put a variable there. Another way to say it is 18 subtracted from half a number. So 18 is being subtracted from half of a number. You can say that. You can say minus, subtracted, decreased by. So different ways you can say this. These are the two that you need to focus on. 18 less than half of a number and 18 subtracted from half of a number. The next one, use the word phrase to write an algebraic expression. 65 less than half the difference of n and 18. So we have half the difference. So 6 and 5/10 less than what? That means this goes last. So we start with half the difference of, remember difference of, you need to put it in parentheses. The difference of what? A number. Difference is the answer to subtraction. So you put that operation right here where it says n. So it should be n minus 18 in that order. And then we need to take 6 and 5/10 from that, because 6 and 5/10 needs to be less than half the difference of n and 18. So that's the final answer for that one. And then the last one, let's look at that. Jacob reads a number of books in July and 8 books in August. During the same month, Marcus reads 3 times as many books as Jacob. Jacob lets B represents the number of books he reads in July. He finds that the number of books that Marcus reads during both months is 3 times the sum of B and 8. Write an algebraic expression to represent the number of books that Marcus reads during both months. So Marcus books that he reads is represented by 3 times the sum. So 3 times means that 3 needs to be multiplied by something. It needs to be multiplied by what? The sum of B and 8. So the sum of B and 8. Remember, sum is the answer to addition. So you take that plus sign, put it right here where it says and. So instead of B and 8, you have B plus 8. And then that needs to be replicated 3 times. So that is the final answer for that one. And that is the warm-up for today.